Hello, my students. We are going to finish off chapters 1 and 2 today. So we are in your notes packet on the very last page. There should be a table that looks like this. We're learning about properties of equality and congruence. These properties are going to come in handy in a few chapters when we start proofs. So this is just a little intro into some of the properties that we will use. So we've got three different properties: reflexive property, symmetric property, transitive property, and we also have of equality or of congruence. So when you talk about them, this box here would be reflexive property of equality. Here we have, down here, reflexive property of congruence. So first I want to address the difference between equality and congruence. When we talk about math symbols, equality will be an equal sign. So we could say something like the measure of angle A equals 90 degrees. When we're talking equality and we're talking angles, we're talking the measure, so the number of degrees that an angle is. If we're talking congruence, we're talking the actual angles. So we don't need the angle measures. So we could say, nope, I just said we don't need measures and then I wrote it. So we could say angle, oh my gosh, here we go. Angle A is congruent. So congruent sign is an equal sign with a little squiggly on top, is congruent to angle B. So here we might not know what the measures of these angles are, but we do know that they're congruent. Alright, so first one we have is reflexive property. When we talk about this, I want you to think about when you're looking in like a pool or a lake or any body of water and you see a reflection, right? It looks exactly like you. That's all the reflexive property is. So we could say the measure of angle A equals the measure of angle A. It equals itself. We could also talk about segments. So when we're talking segments, if we have AB with nothing over top, that means the length of AB equals the length of AB. So reflexive property is just something is equal to itself. It seems silly, but once we get to proofs, you'll see why this really comes in handy and why it's necessary. And then reflexive property of congruence, same thing, we're just talking angles. So angle A is congruent to angle A. Notice there's no the measure of, it's just the angle. And then if we're talking segments, now when we're talking congruent, we need that segment symbol over top there. So segment AB is congruent to segment AB because we're no longer talking lengths. We don't know, we might not know what these lengths are, but we know that they're congruent. Next we have symmetric property. So if you think of something that's symmetrical, so like, now mine won't be, but if you draw a perfect heart, it's symmetric, right? It's the same on both sides. So symmetric property of equality could say something like this. The measure of angle X equals the measure of angle Y. And you want a little if here actually. So if the measure of angle X equals the measure of angle Y, then the measure of angle Y equals the measure of angle X. So it's the same thing, just flip-flopped on sides of those equal signs. And then for congruence, it's the same exact thing. We're just going to talk about the angle, not the measure of the angle. So if angle X is congruent to angle Y, then angle Y is congruent to angle X. Which again, it makes sense, right? If X equals 4, that means 4 equals X. Same thing, we just flip-flop. The last one might be the toughest one to see, but I think it's pretty obvious once I tell you what it is. So transitive property of equality. This says if AB equals CD and So we need two things to happen here, both these things. CD equals EF, then AB equals EF. So let's think about this. If AB is 4, that means AB equals CD, so AB and CD are both 4. Now, remember CD is 4, so CD equals EF, that means EF is also 4. So we can say that AB equals EF because we know that they're both 4. And then transitive property of congruence, it's the same exact thing, we're just going to have a few different symbols. So if segment AB is congruent to segment CD, and remember we need both these things to happen, segment CD is congruent to segment EF, then segment AB is congruent to segment EF. Again, we might not know what these lengths are, but we know that these are all congruent. Alright, that's it for today. See you later.